new slide. Yeah, draw the chemical structure of cis 5-chloro-2-hexene. Again, cis, you see this curving, C, 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 and then the chain kind of continues. The trans, it would not curve. That C would be down here, so it would be more of a ziggy-zag rather than a C. I like to think of it as a C, like that cis arrangement forms kind of a C in the molecule. All right. Would this be a cis or trans isomer? I'm going to circle the longest chain ones. And if I circle the longest chain, what we're going to look at are the two groups that are not part of the longest chain and how they're related to each other. Initially, it's very tempting to look at this and say, oh, cis. But when you circle the longest chain, you'll see that the groups that are attached to the carbon that are not part of that longest chain are trans to each other. I don't like this problem at all. I don't like it at all. Not one bit. I'll be honest. I think it's deceiving. I think it's tricky. I think it's tricky the same way that those other ones were tricky, where there were all those branches and it wasn't obvious which direction the longest chain was. But so this is a trans because the carbon atoms in the longest chain, carbon atoms in the longest chain are on opposite sides. And that goes both ways. So if you're looking at the carbon atoms or not. Oh, I went the wrong way. Okay. So some compounds can have more than one double bond. If that happens, they're called, if there are two, they're called dienes. If there are three, they are called trienes. I don't know what they're going to be called if we go any higher than that, because I don't think I've ever seen it. So this was butene, and I like how it says we insert an A there to ease the pronunciation. So 1,3-butadiene, rather than saying like 1,3-dibutene, we put the di like in the middle of the name. So 1,3-butadiene, diene. So these are called dienes. So you see the word diene kind of in the name. So if you have a diene within a four-structured or a four-carbon chain, it would be called butadiene. The cycloalkenes are very similar to cycloalkanes. The ene indicates that there's a double bond. We have cyclopentene and cyclohexene. There are times that there may be two double bonds. And I think it would be called probably 1,3 cyclohexadiene when we are naming, when we have branches on the cyclostructure, most of the time you're going to see only one double bond there. The numbers 1 and 2 always have to be on either side of this double bond. And to determine which direction to go, if there's only one thing attached, it's always just attached to the number 1. If the number 1 is attached to that, so I misspoke. So let me just draw this another way and show you. So this is a pentene, and we have, let's say we had a group right here. The 1 and 2 has to be around that double bond. So it's either going to be 1, 2 this way, or 1, 2 that way. And we're looking for the lowest number. So because this would be like number 3 instead of 1, 2, 3, 4, 5, going around this way will give us the lower number. This becomes a 1, 2, 3 methyl cyclopentene. This one, 1 methyl cyclopentene. This one, we're going in this direction rather than 1, 2, because this gives us the shortest distance, the smallest numbers. So that becomes 1, 3. They're both methyl groups, dimethyl cyclohexene. There are a lot of tutorials online to practice with naming alkenes, cycloalkenes, alkanes, cycloalkanes, and they really can be helpful. Now when there are 2 double bonds, we again have that diene in the name, and we want to give us, we want to number it in such a way that the double bonds are giving us the lower numbers. So in this way, because they're both on the side, we're going to number in this direction. This becomes 1, 3 cyclohexadiene. Again, there's a diene. Now we are not going to have more than 2 double bonds in a cycloalkene. And I'll show you why. Because of the nature of the way hydrogens are, you're never going to see 2 double bonds next to each other like this. That's just not going to happen. There's not enough structure, there aren't enough bonds for that. When we get more than 2, we end up with this. And we wouldn't call this triene because now we have that whole new structure. Do you guys remember what that is? Benzene. All right, so this is benzene, and that is what makes an aromatic compound, which is a whole different category of compounds. So we had the alkanes, the cycloalkanes, the alkenes, the cycloalkenes, and then we have those aromatic compounds, which are in a class in and of themselves, which I think is at the end of this. All right. So if we name these, as I'm numbering, I have to figure out how I have to number so I get the lowest numbers. These are my options: 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5. Oh, I can't start the 1 there. If I were numbering in the opposite way, I would have to have 1 here, because between the 1 and 2, that double bond always has to be between the 1 and 2. So 1, 2, 3, 4, 5, So what's going to give us the lowest number is if we start numbering this way, and we will have 1 bromo, 4 methyl cyclohexene. In this one, we're going to have to start numbering either here 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or yeah, that's what I did. Having this be number 1 is going to give us the lowest number. So we have 1, 2, 3, 4, 5. We have a 1 methyl. And our double bonds are on the first.
Do the double bonds have to be lowest?
Oh, I think the double bonds have to be lowest. This is so easy to mess up. Yes, the double bonds have to be lowest. Watch me, I'll probably mess it up again. So we're going to have 2 methyl, 1, 3 cyclopentadiene. It is easy to make mistakes. And if I make mistakes, I want you guys to feel free to say, hey, you made a mistake, I think. And I probably did, or maybe I didn't. And if I didn't, and you think I did, then hopefully I can explain why I didn't make a mistake. But please feel free to let me know if I have made a mistake, because I do make mistakes. I will not be a pretentious instructor that will say, I'm smarter than you, I know more than you, I have more life experience, I know what I'm talking about, because we all make mistakes. It's silly to be that way. Okay.
So is that name a mistake? 'Cause that says cyclohexadiene and it's
That is a mistake. Right from the company. That is absolutely a mistake. Good job. Good job. Yes. Look at that. Haha. Nice job. I didn't even spot that. That's how unobservant I am. Okay. So what I want to do right now, in the next little 20 minutes or so, is go ahead and try building the models for the alkenes. And that's going to be the last bit that I talk about on the machine here.